Hi folks, a special welcome to our friends at Eagle Creek Community Church. I want to invite you in to see a preview of our Geology Learning Center. And my wife is getting soaked here because there's some additions we need to make to the outside. But anyway, welcome. We're in, and I'd like to kind of give you just a brief tour. We're not done. A lot of our signage needs to be printed yet, but here's an example of what it will look like. It'll be about this size and color patterns, and then each display is kind of built as a station. So it's just kind of an introductory station of geology, primarily trying to help students, parents, families understand the difference between science and history. A lot of people think that science is one of those catch-all terms that can explain everything, but it can't. It's tied to the present, and so it is very limited. So all the displays are designed to help students develop some discernment in figuring out what exactly is science and what exactly is history. So we start here. We've got several displays. This display really is on geological terminology, where we start learning the language of geology. Very important concept. It's like learning a language. You got to learn the different kind of variations and how things are used, and that way you can begin to interpret just what you see in the world around you. We also have a display on crystals. Crystals are a lot of fun, and important to understand that it's really the science that makes the crystals. Inside the crystals are patterns of electrons, and the electrons line up in a certain way to produce a consistent crystalline form. And so that's what this is all about. Then we move into the flood as an interpretation of what we see in the earth, and offers I think a much better explanation of the fossils. Especially this display is on what we call graveyard fossils. This is where we have mass burials of fossils all over the world. And so this gives a chance for the students to see what these look like rather than just a bunch of rocks. They are special kinds of limestones and shales that contain millions of fossils, and the students can then identify them. We have displays on each one of the fossils that are represented in the limestone. These are invertebrate fossils, that is, animals without a backbone. So these would be primarily sea animals. The sea animals are the most abundant type of fossil in the fossil record. Here's a real specific display on invertebrate sea creatures. And so these are very plentiful, and you just have to keep your eyes open. One of the things about invertebrate fossils, though, is that the fossils really indicate that things were much larger in the past. And you see a lot of that represented here. Vertebrate fossils, vertebrate marine fossils. And of course the big mystery there is, what was the megalodon in the very back? Huge teeth. And trying to figure out how he fits into this whole thing. He's apparently extinct. And so we try to offer explanations of that. In the corner is a reproduction of an actual femur bone from a Camarasaurus. You see him illustrated up there. One of the first discoveries in the dinosaur wars. We'll have that all told here. That femur is the bone from your hip to your knee. So you can just imagine then how big of a creature this was. Dinosaur bones, and one of the big observations about dinosaur bones is that they are most often disarticulated, which means they're broken up. You don't really find whole skeletons, generally speaking. And we have same with a lot of mammal fossils. The petrification process was the same for both mammals and dinosaurs, which would lead you to believe that we're looking at one and the same process involved in the flood. Dinosaurs, of course, were created on day 6, along with mammals and also man. So there wasn't a whole lot of time between dinosaurs and mammals. And then we move into rock displays, various types of rocks. No one has ever seen the plutonic rocks form, so it's a mystery. We generally tie those to the creation rocks. We discuss metamorphic rocks and the metamorphic processes involved. And there I use, for kids, I use my handy little jar illustration with various kinds of baking chips. And the more heat and pressure that's added, of course, the more warped the rocks become. And that is pretty much what's thought to be represented in metamorphic rocks. Let me back up here. We're on one side of the room, but then we have an inside portion. Inside will be our classroom. Take up to 15 or 20 students here where I can do classes. There's an actual cast of a T-Rex skull in the corner with Pteranodon resting on his head. We're just trying to figure out how to get him up, strung up over the rafters. And then the famous Velociraptor sitting the opposite side of that little room. He's the one that chased the kids around in the Jurassic Park movies. And there they call him Velociraptor, but he really wasn't. Kids will recognize him as Velociraptor because of that. But his name is really Deinonychus, meaning terrible claw. And so you can see down below, that's why he got the name, was because of the pattern of his foot. We also have some very interesting displays that are designed to get people to think about the flood and the processes involved in the flood. This whole box of material is from the Chicago area, known as Mason Creek. And in it are fossils all jumbled together from land plants to sea plants. Land ferns, shrimp, there are sea cucumbers, bristleworms, seed pods, clams, jellyfish, all mixed together in one formation. And ever since the 1970s, geologists have been discovering these all over the world. Today, there are about 230 different locations just like this all over the world. And that is very interesting. Displays of cephalopods. For some reason, these went suddenly extinct. These are sea creatures. There's only one representative today, seemingly, and that is the nautilus. Every other one of these are extinct. Now, why would they go extinct suddenly? Well, I think a good explanation is just the dramatic impact of the flood. And then here's a funny demonstration, a funny part here. I like to collect poops, fossil poops, and the kids get a real kick out of these. But that brings up the question, how do you get soft material like a poop to petrified? If you've ever watched your dog, you take him out for his morning constitution and keeps visiting the same spot. Sooner or later, those poops, if they're not dried up and blown away, will turn white and then blow away. They don't ever petrify. How do you get petrified poops? It's one of the big questions we ask here in the Geology Learning Center. They can see some of the things involved. And then I have, of course, dinosaur tracks, eggs, teeth. These are all favorites of kids. Most of the teeth are real. I do have some reproductions. The 2 eggs that are real are here on the end, and then these are reproductions or casts of authentic eggs. And then the disarticulated nature of dinosaur bones, we have a big display of those. These were all found by me and our various tours as we've taken them to the dinosaur fields in eastern Montana. They are all over the place, but they are disarticulated. We have some interesting reproductions of things, but notice they are all disarticulated. For instance, the Allosaurus foot was found just like that. It's a reproduction of the original one found in Colorado. And then, of course, parts of dinosaurs. Skulls generally preserve the best because there's so much bone material. Another example of the flood would be the death pose. These are reproductions of fossil dinosaurs. This one here is Archaeopteryx, which was a bird. But notice the head is cocked back and is known as the death pose. It's a common feature when dinosaurs like this are preserved in the fossil record, indication of suffocation by mass burial. Wood is another one of those things, one of those prolific fossils in the record. Why? Why do we have so much petrified wood? In the forest, they eventually deteriorate and blow away. But here, you can see these all have something very beautiful about them that's not part of the petrification process as much as the filling process. All of this wood was saturated with mineral-rich water, and most likely from the volcanism that took place around the flood and shortly after. And so these were all what we call mineralized. Same way with leaves. Here's a collection of actual leaves. Most of these are from the southwest portion of the United States, and they're all exquisitely preserved. So we talk about the process of preservation, and we'll pick up over here with our sedimentary rocks. The sedimentary rocks, of course, not being formed today like we see in the record. And most of these are preserved much the same way as you see the fossils. You have mineral-rich sediments. And then those tie in nicely with volcanic rocks. Here's a bottle of ash from Mount St. Helens. Ash is mostly bits and pieces of volcanic rock and glass. And it's the glass that accounts for the real pretty lavas not being formed today, by the way. In fact, there are just a couple of rocks here that were produced in modern times. This one here from Hawaii, a very black rock. These others were preserved at some other point, most likely flood and post-flood. And then we have some Mount St. Helens ash here, and then Mount St. Helens pumice buried in the rocks there. I haven't finished putting all of this together yet. But the beautiful lavas are not being produced today. And speaking of lavas that are not being produced today, this is at least a portion of my thunder egg collection. Thunder eggs are balls of lava with all kinds of patterns of silica or quartz or agate. These are not being produced today. No one knows how they've been produced. You'll get bunches of explanations, but no one can figure it out. I think it has something to do with the mineral-rich earth right prior to the flood. And then this is one of the most fascinating displays to me, and this is on fluorescent rocks. We'll add this to the end. We can turn off the lights and you can see what it looks like. But take a good picture in your mind of what the rocks look like, just regular old rocks. And then again, agates, not being produced today. No one knows how they're formed. They think they are related to volcanism. That I would agree with. It's all glass. And it's the different metallic elements. Those of you who are chemistry minded, in the transition element section of the periodic table, that's what gives all of these their colors, their beautiful colors. There's a big display right behind here with petrified wood. All of this I've collected and tumbled, and tumbles nicely because it's all wood that has been preserved in an abundance of glass. And then we discuss the issue, we're not quite done with this particular display, but it's the issue of radiometric dating. And we use the egg timer here, showing that the things that have to be true in order to turn radioactivity into a clock is, of course, the sediment that's pouring down through, measuring the time, has to come consistently all the time. You can't interrupt it. It has to not be blocked, and you have to know the amounts you're working with in order to have it work like an egg timer. So we talk about that. We also tie geology and biology into history. This is a display of some of the artifacts that have been discovered through the years that really demonstrate the reliability of the Bible. I don't think there's a year that's gone by in any calendar, in any year, in any group of years, where something hasn't been discovered in the Israel that doesn't in some way support biblical writings. We even have a reproduction of Lucy. Now, this is the one that travels with museums as they go around the world. No museum ever travels with the original fossils. And so these are casts of the original. And so you don't have to pay your $50 to get in to see the museum. You can see it right here. And if you come visit us, you can see it right there. We also tie in biblical history to interpretation of the events and artifacts we find. Of course, the Tower of Babel was a real event, happened just about 125 years after the flood, and can account for the spread and development of the nations afterwards. And then the tabernacle. Most societies have some kind of central god they worship. And here, the tabernacle, originally set up to remind Israel of God, their provider. And of course, the tabernacle had the sacrifices. And it was to be set up right in the middle of all 12 tribes. They were to camp around it, to remind them that God was the center. And the things that went into the tabernacle, of course, are gold, copper, silver. And so the different skulls and stuff we find, fossil skulls, all relate to the history of man in some way, or the history of apes. All the skulls can be divided into two groups, man-like, ape-like. And it's the imagination that ties them together in some kind of an evolutionary order. So this table has a display of jaspers, or the opaque polished stones, and the agates are the translucent polished stones. We have a nice big display on Washington geology. Of course, the big thing about Washington geology, we have a lot of the ice event preserved here in the state of Washington, along with, of course, the volcanoes. And so we learn about Washington geology. Minerals, many minerals, of course, were part of the original creation. Some might have been the result of chemical reactions as a result of the flood. We have a display on the Enlightenment also. We don't have that up, but the Enlightenment is really what caused man to start changing his views of the evidence. And a lot of that's tied up here. One of the things is what we call irreducible complexity. And the very simple idea is that a very simple mousetrap has three parts to it that must be there in order for it to work. And if any one of those parts are gone, it won't work. And it's the same with the cells and the different things of life. Either all the parts to function, all these little organelles in the cell, all have a major function. If one of those is missing, the cell won't work, and it will die. We have a display on Yellowstone, one of the biggest volcanic eruptions in Earth history. My favorite spot to visit. We conduct tours there every year. We go to all of these various places and allow the kids to collect rocks at different places. Also within the Yellowstone ecosystem is the Lewis and Clark Caverns. We do take tours to that too, and understand cave formations, how the flood played the initial part in their formation. Geodes are really nothing more than miniature caves. They're sedimentary in nature. So you're looking at small caves. And then a table to kind of tie up everything, titled, "Can the Flood Explain?" And so we ask the question, how does the flood explain earthquakes? How does the flood explain the lavas that are no more being formed? One of my favorite parts of my collection is this sea creature. We call it an ammonite. I had a big display over there on the other table. That one was found in a coal mine. Coal mine, of course, consists of land plants like these. These were found in the same coal mine. How did a sea creature get into the coal mine? And then this one's a very interesting feature back here. It preserves what we call percussion marks. It's like taking a hammer to a board. Just west of Yosemite Park in the Merced Valley there along the Merced River are these boulders. This is the smallest one I could find that I could carry out. But most of them are big as cars, and some are as big as houses. And they all have these percussion marks indicating a lot of violent tumbling of some kind. And of course, the Southwest is filled with fossil ripple marks, raindrop splatter marks. And these are all mysteries that I think are best explained by the flood. So that's our Geology Learning Center. One more thing I want to do, and I'll have Vicki turn out the lights and make her way back, so you'll be in the dark for a little bit and suspense will be building. dark, I'm still here doing just your computer screens and TVs, whatever you're watching on. Then I'm going to pop you into the world of fluorescence. I'm still here. Okay, she's here. Here we go. Ready? This is fluorescence. Now, this is only observant in about 12 to 15% of the rocks and minerals. And that's a mystery in itself. Why only 12 to 15%? Why not all rocks and minerals? And it's because something has happened to the atomic structure. This phenomenon called fluorescence is the movement of electrons that are affected by fluorescent light. And it's a phenomenon that only a few of the rocks and minerals possess. I'm going to lower the light here and you can see what happens. Some continue to glow because their electrons are slowing down, but as soon as the electrons come in contact with the fluorescent light, you can see what happens. Anyway, this is one of my favorite hobbies in geology, is the fluorescence. And it's kind of a wow factor to it. So that's fluorescence. Find your way back here. So that's the Geology Learning Center, and we're not quite done with it, but we are really having a lot of fun. Vicki did the artwork. The big mountain background is Mount Adams, which is only about 50 miles from here. It's a big stratovolcano. And then over here to the right is the top of Mount Rainier we can see. It's just off to the right. And in between the two is Mount St. Helens. Now, of course, when Mount St. Helens erupted, it lost about 1,500 feet of its top. So it's really hidden by the mountains between here and there. But this is what we want to devote to helping families especially learn what geology really is and what it is not. So I hope you enjoy this. If you're really motivated, we appreciate your financial support on this. It takes a lot of money to put things together, and I know several of you have donated a lot, and we thank you so much. Wouldn't have been able to do it without it. In fact, we had an accident here just the other day where our heater just suddenly quit, and so we had to buy a new heater, and it is working very, very nicely in here. So anyway, thank you so much for your prayers and your support, and we hope to see you visit here one day. Bye-bye.